let's review just a little bit here first. So I need everyone to make sure they're giving me their full attention, okay? We're going to review, make sure your brains are engaged, and then we'll continue with the notes and finish up, okay? So we completed this review a little while ago. Let's see if we can do it again, but together as a class without our notes. So, number 1, what is an atom? We'll give you a good answer for that. What is an atom? Bella? Very good. It is the smallest particle into which an element can be divided and still maintain properties of that element. Is it the smallest you can go?
No.
No. You can get smaller than an atom. It just will no longer behave like that element. Okay? What about number 2? What is a molecule? What is a molecule? Actually? Very good. 2 or more atoms that are chemically combined. Let me ask you, do they have to be different atoms?
No.
Ashley? No. Do they have to be the same? No. Do they have to be 2 atoms? Only 2? 2 or more. Very good. Yes. Let's get through class and then snack break. I'll take you. Okay. All right, good. 2 or more atoms that are bonded together. They don't have to be different. They can be the same. They could be different. Okay. But as long as you have 2, 5, 500, 50,000, you're going to have a molecule. Okay. What about number 3? What is a compound? How is this different from this? Parker?
A compound is 2 or more elements, different elements that are combined together.
Okay. And a molecule is just 2 or more?
2 or more atoms.
Very good. Compound, 2 or more different kind of elements. If you look at the molecular structure of that thing, you have to see more than one kind of element. Make sense? All right, let's do number 4. We're going to fill in the blanks with either molecule or compound. Okay? A blank is always a molecule. What are we going to write here, class?
Compound.
Compound. A compound is always a molecule. Is that true?
Yes.
Yes. If you're going to have 2 or more elements that are bonded, you automatically have 2 or more atoms that are bonded, right? So you automatically have a molecule. But how are we going to fill this in? Raise your hand. A blank is not always a blank. Reagan?
But a molecule is not always a...
Okay, a molecule is not always a compound. Explain what you mean by that.
Because molecules, they can be 2 or more atoms, they can be the same, but compounds, in order for it to be a compound, they have to be 2 or more different elements.
Very good.
They can't be the same.
Very good. So, I could have a molecule that has 2 elements bonded together that are the exact same, correct? Is this a molecule?
Yes.
But is it a compound?
No.
No. So a molecule is not always a compound, but a compound is always a molecule. And number 5, what is the last name of the guy who first attempted to organize all these elements into a chart? What do you think, Anna?
I don't know.
You remember his first name?
No.
You remember what it starts with?
No.
Not even a guess?
No.
Noah?
It's like the Mendeleev guy.
There you go. Mendeleev. Dmitri Mendeleev. Okay? Very good. All right. Now, let's review from the periodic table a little bit, and then we'll finish up the notes. All right. On the table. Okay? What do we call this part? The 1 or 2 letter abbreviation for the element. What is that called? Landon? The atomic symbol. Very good. Okay. What is this blue number called? The whole number that goes up by 1 every box. Nicholas? Atomic number. Very good. And that number tells me what?
How many protons
Are in
are in the atom?
1 atom of that element. Very good. So how many protons are in 1 atom of potassium?
19.
Very good. 19. Okay. What is this red decimal number at the bottom called? Not a whole number, it's a decimal. This was kind of new. We learned it on Friday. Parker?
The atomic mass.
Very good. The atomic mass. Anyone remember the unit that we measure atomic mass in? Trinity? No, not kilograms. Good guess though. It's not units. It's a little more than that. It's something unit.
Oh, it's in the back of my shirt.
Right to the front of your head. Even?
Oh, I think I know. Atomic unit.
Yes, atomic unit. Okay, abbreviated AU. Always measured in atomic unit. Okay? Alright. Alright, let's do this one. Let's do, looking at gallium, Ga. What group number is gallium in? That's what might get you. What group number? Caleb? 4? Gotcha. That's the period number. What's the group number? Try again. 13. Very good. Group number is up and down. Okay? Gallium is in group 13, but it's in period 4. Period goes across, left to right. Calm down. Don't do it. Okay. Alright, then the last thing we learned was the different groupings on the table. Okay? What are the two main groups on the whole table? Most atoms are either this or this. Bella?
Black letters or clear letters?
Well, yes, but that kind of has to do with this. Not quite look at board. Like all of these are this, but these are this. There's this kind of clear separate line right here that divides it. Nathan, you remember?
No, but I just want to say.
Ooh, thank you. I'll give that to you in 1 second. Hannah? Very close. Metals and then non-metals. The opposite. Okay? Most of the chart is which one? Metals, non-metals? Metals. Anna, you with me? Most of them are metals. Okay? About right here, we have some that are kind of middle ground or metalloids, but the rest of it are mostly non-metals. Okay? And that's what we're going to pick up today. So, go ahead and turn back to your notes where we left off. I believe we're on the second, third page, somewhere around there. Perfect. Caleb, question? Nothing. They're the same thing. Atomic symbol is a little more specific, I guess. Oh, no, wait. Before we get to that, hold on. We got to review ions and isotopes.
We've already been to this spring.
Okay. Ions and isotopes. Let's use an atom of the element lithium. Okay? Lithium is symbol Li. So, looking at the chart, how many protons are in one atom of the element lithium? Anna? Alright, you don't, not on me. Don't do it again. Okay, lithium is the symbol Li. Looking at the chart, how many protons are in one atom of the element lithium? What did I find it? Li. In the top left. Come on. Do you see Li? You can stand up and go closer. And you know how many protons? No, that's atomic mass. I need to know the atomic number. 3. Exactly. Okay, put that away. 3 protons of one and 1 atom of lithium. Okay? If there are 3 protons, how many neutrons are there probably? Kayla? 3. Good. So 3 neutrons. Okay, which have no charge. How many electrons are in one stable, meaning non-charged atom of lithium? Reagan?
3.
3. Very good. So I'm going to put 3 electrons spinning on the shell around the outside. All right. So this is 1 atom of the element lithium, yes? All right. Now, what if I add an extra electron? Now what do I have? What do we call this atom? Connor? Well, let's start with this. Do I still have lithium?
Yes.
Yes, because I have 3 protons still. But what kind of lithium atom? Not an L, but it looks close to an L. All right, I'll give you a multiple choice. Ion or isotope? An ion. Very good. This is a lithium ion. When you change the number of electrons, you have an ion of that element, yes? All right. What kind of charge does this ion have? Positive or negative? Bella? Why negative? Why negative? You're right, but why? Oh, oops, sorry, you're wrong. Negative, but why negative?
Oh, wait, because you added another electron, and the electron had a negative charge?
So which one is more, negatives or positives? Good. Because I have more negative charges than I have positive charges, the whole atom has a negative charge. So a lithium ion with a negative charge. How could I make this a lithium ion with a positive charge? Landon?
So if you made a lithium ion with a positive charge, it wouldn't be an ion anymore because the positive charge
Well, if I add 2 protons, I no longer have lithium. Now I have boron. I want to make a lithium ion with a positive charge. How can I do that?
Oh, take away 2 electrons.
Very good. Okay, take away 2 electrons. Now I have more positives than negatives. I still have an ion, but it's a positively charged ion. Okay? All right, let me ask you this. How would I make this one little lithium atom into an isotope? Parker?
I think you would make the number of neutrons the most.
Very good. Well, not the most, but you would change it. I could either take away neutrons or I could add them. Okay? But keep in mind that will not change the charge because neutrons have no charge. All it does is change the mass of that atom. Will it be heavier or lighter? Sophie, with me? Okay. What if I do this? Now what do I have? Patty?
It's just a completely different.
Good. Which atom is it?
It would be. I don't know where that one is. I think I know.
The symbol. What is it? Be, which stands for beryllium. Okay? Be. Okay? But let me ask you this. Do I have a regular atom of beryllium?
No.
What do I have? Yeah. Connor, what do I have?
You have a positively charged, that means an isotope?
Not an isotope. The other one. Ion. Very good. It is a positively charged beryllium ion. Okay? Nicely done. All right, now picking up where we left off. I'm actually going to flip over to this. And Nathan, don't let me forget, I'm going to get you the key for the notes here in just a little bit, okay? But I'm going to flip over to the dot cam because this gets a little bit complicated. All right, you'll see in your notes that I gave you a couple different periodic tables. We're going to actually draw the different groupings in our notes for metals, metalloids, and nonmetals. Okay? Okay, so the elements on the left side of the table contain the greatest metallic properties. Okay? They are the most metallic. They are great conductors, they're shiny, they happen to be highly reactive, etc. Okay, do we have this already?
Yes. No, we did not.
All right, fill them in. Okay. Then below that, we're going to go ahead and circle the metals group. Okay. So using your pencil. Make it a little bit bolder. Okay. We're going to circle all of the ones that are metals. Now, be careful because it does include all of these on the left side except for hydrogen. Okay. There is a reason why he has to be in group number 1, but remember, he's kind of a loner. Okay. We leave him by himself for a while. So, but it includes all these other elements here. Okay. Now, over here, all right, the division between metals and non-metals gets a little bit funky. Okay. It's like a stair stepper. Now, depending on what kind of chart you're looking at, this dividing line could be a little different. Some people include GE in the metals. Some people maybe include AS in the metals. Some people include SN in the non-metals. Okay? It just depends on the chart you're looking at. It's kind of like this. Some people, it's like my hair color. Some people look at my hair and think I'm brunette. Some people think I'm blonde. Just depends on your opinion of the matter. Does that make sense? That's kind of how this is. All right? This divider line changes based on different scientists' opinions. Okay? Yes.
So, is that, PO potassium?
This one down here? No, potassium's over here.
Oh. Well, still, potassium does not seem like a good metal.
I know.
Because it's highly reactive with something.
That does not make it a metal, though. But yes, it is highly reactive.
It's in one of the highly reactive.
Okay? All right. Yes.
Oh, but also, what about the lanthanides?
Okay, lanthanides and actinides. You could include them in the metals,
Because
but
when you circle the whole thing, you circle these guys.
correct. But they're also kind of their own grouping, so I don't really include them, but you could. Okay? All right. As you move from left to right on the table, the elements become less and less metallic. Okay? So, rubidium here is more metallic than SR, whatever that is. Okay? Which one's more metallic? Niobium or molybdenum? Which one is more metallic or more like a metal? Niobium or molybdenum? Trinity? Niobium, because it's more to the left. As you go this way, the elements get less and less metallic. Okay? Now, there is a little section of the table that we say is kind of like a metal, but kind of not. That little section we call metalloids. The middle of the table is called metalloid elements because they have properties of both metals and nonmetals. Yes.
Is it like some sort of this? There's this thing that, or there's like this substance that can turn into a solid if you move it around, but if you just sit there, then your hand turns into a liquid.
Correct. That is gallium because it has a very, very low melting point.
Which one would it be?
Gallium is right here. So it is a metal, but it's really close to being a non-metal. So it's not a great one.
Wait, so do people sometimes put it in non-metals?
I don't think so. I think everyone pretty much agrees that it's a metal. It's just a very bad metal. It's not great at being a metal. Alright? So, for metalloids, you're going to put your little box around this section. It's kind of the stair stepper there in the middle. Nope. Just your pencil right now. It's fine. We're not color coding yet. Yes.
So, is gold kind of a metalloid that's beside it?
It's not a metalloid, but it is one of the less metallic metals because it's all the way over here. Or, sorry, all the way over here. No, it's AU. Okay? It's going to be kind of your stair stepper there in the middle. Yes.
So you added GE. Oh, I thought you added GE in the middle and.
Nope. I didn't include GE in the middle. Reagan?
I'm not sure if this is correct, but is number 5 boron?
Correct. Okay. Now, again, depending on which chart you're looking at and which scientist made the chart that you're using, this section could maybe include AL, it might include VI or PO, or maybe include SN or maybe SE. Just kind of depends on opinion. But I just want you to know the general area where it is. Okay? Landon? Yes. Boron? Why is it a what? They're not in circles?
He's talking
Confused.
about if they're in a if that individual.
Because it's in the corner. Yeah. Okay? All right. Then lastly, on the farthest right of the table, the elements become nonmetals. Now, don't forget about hydrogen though. Okay? He is a nonmetal. He's just way over here. And there's a reason why he has to be in this column. And we're going to get that tomorrow. Okay? But over here, hydrogen. Nonmetals may be solid, liquid, or gas at room temperature. Okay? So nonmetals are all the elements to the farthest right, and hydrogen from way over there. Just go all the way over. Okay? Now, once you've completed that, then I want you to turn to notes number 3. Parker?
On the test, do we have to like label all this?
No, but it will help you answer some of the questions as far as like, okay, if it's over here, I know it's a nonmetal. But no, you want to know the division. Yes.
Mercury. I'm pretty sure mercury is also like it's not a gas at room temperature, but it is a
Liquid, correct. It is the only metal that is a liquid at room temperature. Hence why it's blue. Ethan? Nathan?
How come mercury always puts
Always what?
How come when you put metal, mercury in it, supposed to put mercury
And thermometers. They used to put them in thermometers because it was like that red line that would kind of go up as it gets hotter and down as it got colder. But I think it was actually poisonous, so they use something different now. But they used to use it in thermometers. Okay. All right. Hold on. We have fun right now. All right. On notes number 3 now. Okay. This is where you're going to use either your colored pencils or your markers. Okay. Either one is fine. Just make sure you have them out, basically. Okay? Then you're going to want to turn your table to the side, so you're looking at it the right way. All right? First thing we want to make sure is that your group numbers and period numbers are labeled, which this chart gives them 2 labeled already. You have period 1, 2, 3, 4, 5, 6, and 7, and then groups numbers 1, 2, all the way up to 18. Okay? Caleb? If you want to borrow some markers, you can. They're up here in the drawer. Yes? Pardon? About 6 or 7. Maybe 8. Just 10. Okay, if you're using colored pencils or crayons, you can go ahead and color them in. Okay? It'll end up looking something like this when you're done. Okay? If you're using markers, I'll show you how to do it up here. We're just going to outline the sections. Otherwise, if you color them in, it gets too dark and you can't read your table anymore. Okay? So, we'll start with the metals over on the left side. Okay? So pick a color. Doesn't matter what color. It can be any color. All right. But you do want to have your code at the top. Okay. So our first group is going to be the alkali metals. Doesn't matter what color. You can use any color. I'm going to use red, but you can use pink for all I care. Did you get all the ones you're missing?
Yeah, just that one.
Oh, perfect. Okay. So the alkali earth metals is basically all of group 1, except don't include hydrogen. So from lithium all the way down. Again, if you're using marker, outline just like I'm doing here. That way you can still read your chart later on. Okay? The alkali metals are very good metals. They're great conductors. They're usually solid at room temperature. Typically they're shiny, okay? But they're also highly, highly reactive. If you remember the video we watched of the sodium being chucked into the pond water and creating that big explosion, sodium is right here, number 11. Okay? He belongs in this alkali metal section. Okay? Next, pick another color, doesn't matter what. These are called the alkaline earth metals. I have no idea why they're called earth metals, but they are. Okay? These are all the elements in group number 2, so right next to the alkali metals. These are reactive, they're just not nearly as reactive as the alkali metals. Okay? They're still good metals. They're on the left side of the table. They're pretty metallic, so they're still good conductors of heat and electricity. Usually solid at room temperature, just not as reactive. They're a little less reactive. Ethan H?
In that video we watched about the sodium exploding on the pond,
Mm-hmm.
it found fire on water.
Yeah, I don't know. That's a great question. Okay. All right, our next one is one of the biggest groups on the whole table. These are the transition metals. Okay. Now this one gets a little bit funky. Okay. It does include scandium, number 21, and 39, yttrium, however you say that. Okay. But it does not include Lu and Lr. So it's almost like a straight box, except for those two. And then it goes all the way up to group 11. Okay? Now, these are called transition metals because these are the metals that are kind of transitioning from being really good metals to really not good metals over here. Okay? Transitioning or changing as you go to the right. Yes?
Thank you for making one of the biggest groups on the chart. Well, not but like
Categories?
yeah, categories on the chart.
Okay? Then the transition metals get us over to the other side of the metals category. These are the poor metals. They're kind of metals, they're just not really good at it. Yeah. Okay. Now your poor metals will go right up and bump up against the Seyre-Sepper line. And then we'll go all the way down. Connor?
I know 118 has three letters now, but it looks like OG stands for orange.
It does.
And you used orange.
Almost. Okay. Okay. Next, we'll move out of the metals into the non-metals. It's going to be our next group. Okay. Now, that is the other side of the stair stepper. Except it does not include group 18. So not that last column. Reagan?
I thought mercury, zinc, and Copernicum.
Cadmium, you mean? Oh, 112.
I thought they were all transition metals.
Okay, so again, the divider line between some of these can sometimes, depending on which scientist makes the chart, could be a little different. Okay? Hold on. All right, next we have group 18. These are the noble gases. Okay? These elements do not bond or react with any other element. Okay? They're just chilling over here. They're enjoying life. They don't cause any problems. They exist by themselves. They don't react.
They're like, I'm lame.
Actually, I kind of think about it like they're pretty happy with themselves.
Neon's at least the only cool one.
Mm-hmm.
And then radon, it used to poison people because they thought it was like supposed to be the super cool, super healthy drink, but then it just reacted. Radioactive.
Interesting. Okay, and then the last two groups are kind of already labeled for you. It's the lanthanides and actinides. And I ran out of colors, so I'll use highlighter.
It's the same color as yours.
A little different. Okay. Hold on, I'll get to it.
What's helium?
Not helium, hydrogen.
Hydrogen, okay.
Alright. So Landon asked a good question. What about hydrogen? Don't forget, hydrogen is kind of in a group all by himself. Okay? So if you want to, sometimes I just leave him on his own. Sometimes I'll just make him a little separate group by himself. But he is considered a non-metal. He just doesn't really follow any of these categories. Okay? He's kind of a loner. He's special. You can either do like a little bubble like I did. You can leave it blank if you want. You can do it black if you wanted to.
Yeah.
Okay? Okay, so I'm going to let you finish up your charts here in just a minute, okay? But real quickly, I want to go over the homework, the review paper with you. Actinides. It's right here at the bottom of the page, too. See my finger? Okay? All right, hold on. I'll get your questions in 1 second, okay? Let me go over the homework real quick, and then I'm going to give you time to work on both the chart and the homework. Okay, so everyone pause where you are for a second. All right? Let me go over this paper with you.
If you can get the paper.
I can find it. All right. First part of your homework. Everyone look up here. Pause what you're doing for a second. First part of your homework is labeling the parts of the atom. Okay? Now, aside from the vocab note cards that you're studying for the quiz, this is the other part that will be on the quiz. Okay? So you can draw arrows if you want to the different parts. You can actually like make little lines and label them if you want. Either way is fine. But keep in mind that when you label the nucleus and the shell, you either have to be very particular about what you're pointing to. Okay? If you think that you're pointing to shell here, but you're actually drawing your line here, that's going to be wrong, right? That's an electron. Okay? If you want to, you could also thank you. You could draw a bracket around the whole thing. Okay? All of that could be the shell. Same with the nucleus, right? This whole thing is the nucleus. If I wanted to do that, I could. Does that make sense? Just be very careful because this and this are both bigger sections than just pointing to one part. Yeah, arrows is fine. Okay? Caleb and Bella, you have a question on this part? Okay, Bella?
Is the nucleus and that one just all of the first one?
It's the entire middle part. You got to find some way to point to that whole entire middle part. Okay? Caleb? Okay, I'll get to that in a minute. Connor? Question on this part?
So we're allowed to do the bracket around the whole shell?
Yeah. Okay? Alright, then, hold on, look up here. Stay with me, I'm not done yet. Number 2, what is the name of this element? Talking about this picture up here. Now, be careful, okay? Because, and I'm going to give this to you 1 second, okay? There's notice, there are 1, 2, 3, 4, 5 protons, 1, 2, 3, 4, 5, 6 neutrons, and 1, 2, 3, 4, 5, 6, 7 electrons. This diagram is actually pretty terrible, okay? But because there are 5 protons, we're going to act like this is just one atom of boron. Okay? 5 protons is B up there. Does that make sense? Okay. So, it is the name of the element. What is the atomic number? Draw and label an ion of this element, which keep in mind that just means a different number of electrons, right? Yeah, I know. Number 5, draw and label an isotope. What's going to change there? Not the protons.
The neutrons.
The neutrons.
That thing is.
Landon, shush. Trinity, question? You can just make sure you have the same number of protons and neutrons. The only thing that should be different here is the electrons. Only thing different here is the neutrons. Okay? Now, when it says label, all I want you to do is label the protons, electrons, and neutrons. So just kind of point to them. Okay? Then on the back, the last couple questions. Draw and label an atom of hydrogen. Draw and label an atom of oxygen. And then fill in the questions here. Okay? You take this one. I have all my instructions on. Okay? Yes. They should be, a regular atom should have the same. So for example, boron, if there are 5 protons, it should have 5 neutrons, 5 electrons. That's one regular atom. Then if I'm going to make an ion, change the number of electrons. To make that isotope, only change the neutrons. They all, correct. So boron will have 5, 5, 5. Yeah. Carbon will have 6, 6, 6. Nitrogen, 7, 7, 7. Okay? Landon? Two what? Correct. Well, you're in a drawing 4, because you get 2 more in the back, too. All right. And then Caleb made a good point. I left out Lu and Lr. Lu goes with the lanthanoids. And Lr goes with the actinides. Okay? If you have finished your chart, I'm going to go ahead and pass out the homework for you to get started. If you haven't, that's okay. You have the remainder of class to finish the chart and work on the homework.